Hello and welcome to my video series on embedded C. Now in this video I'm going to look at the arrow operator. Introduction. Now the arrow operator is made up of two symbols. The first symbol is the minus sign and the other symbol is the less than sign. Now together they form this arrow operator. Now the arrow operator basically allows or enables the programmer to gain access to the data of the members or the elements of a structure or a union. Now the arrow operator is generally used along with a pointer variable. That is, the pointer variable stores the address of the variable to which the pointer points to. Let's take a look at an example. And here in this example, I've declared a structure type. The struct here has a name called access data. And in this structure, there are two members or two elements. The first one is pin of the type int, and the other member is called zone of the type unsigned char. So let's go through the rest of the code. First one I'd like to talk about briefly is the struct access data address. Basically here we declare a structure called access data and a structure variable called address. The next line here, struct access data asterisk code pointer. Basically here we declare a pointer variable to the structure called access, the pointer variable being code pointer, and notice the asterisk. And I'll skip this other parts. Let's move on to this one first. Code pointer assign ampersand address. Basically this line of code assign the address of the structure variable, the address of the structure variable address to the code pointer. Notice, as I mentioned earlier, the ampersand sign indicating that this will be an address, a location of this variable called address. A little bit confusing, but I think you get the point. Now, for the rest of the code, here Init Timer function here, basically I'm using this because I'm going to use the serial terminal. I'm going to use the 8051 to output data on the serial terminal. And here is another function called that will actually print the data I want to the serial terminal. Now the rest of the code here, basically we are accessing the structure members. Here in this line, I've assigned 4055 decimal to code pointer pin. And here I've assigned uppercase C to code pointer zone. And here we have code pointer pin been assigned to port 1 or P1. And here we're getting the serial terminal to print code pointer zone to the serial terminal. So let's proceed to the code demonstration. All right. Okay, so we are here in the Kyle IDE with I've uploaded the code, demonstration code here. So just let us briefly go through the code. So I have to include the reg52.h header file. Here, these two header files here, the Init Timer.h, that is to initialize the 8051 timer because I'm using the timer to assist me to display data onto the serial terminal. And here, the serial print.h is a header file to print the character that I want to display onto the serial terminal. And here, this code here, the first step is to declare a structure type, and the structure type is access data with two members, pin of the type int and zone of the type unsigned char. So these are the two members of the structure type. And in the main function, is the first thing to do is to declare a structure variable. In this case is address. Address is the structure variable, and also a pointer to the structure. And in our example here, we have asterisk code pointer. This is a pointer to point to the access data structure. Next is the init timer. As I mentioned earlier, this is to initialize the timer, preparing the timer to display information onto the serial terminal. And here the code pointer is assigned the address of the pointer. So that is done with the help of this ampersand, so that this will give the address of this pointer to the code pointer. And then finally here, this portion here, we are getting access to the structure members. So here I've assigned 9355 decimal to code pointer pin with the using the arrow pointer, and here I assign uppercase C to code pointer arrow operator zone. And here I send code pointer to port 1 or P1, and here I'm using the serial print header file to print code pointer zone onto the serial terminal. Right, so let's do a build. I don't expect any problem because I've done that earlier, but anyway, I've done it again. So go to debug now to start the debug session. So I'm going to single step through the code here. So I'm going to use F10 to single step. So initialize the timer, assign the address of the struct to the point of the pointer to code pointer, and we can see this. Wait a minute. Address has the value of hexa 08, and this line here basically assign that address 08 to code pointer, and you see it here. We can see it here. And next thing is to assign 9355 decimal to code pointer pin. So yeah, and we have 2488B. That is in hexa. That is the equivalent of 9355. And just watch out for 8B, all right? So, and then we assign the uppercase C to code pointer zone, and we can see it here, the bottom right hand corner. That's been done. And then let me switch over to the serial terminal first, and then watch this parallel port. So we output code pointer pin to the serial port 1 or P1, and you see if we just scroll back, alright, sorry, let's go to the watch. We are supposed to look at 2248B, but remember the code pointer pin itself is an int, which means it's 16-bit, it's 2 bytes, but the parallel port is only 8 bits, 1 byte. So it's only displaying 8B, because if you check this out, the first 4 bits here, the most significant 4 bits is 8 in binary, and the lower 4 bits, it's B in binary, which is 1011. Now, and so that being displayed, only the lower byte is displayed onto the parallel port 1. And then finally, let me switch over to the serial terminal. We have watch the serial terminal. We should see uppercase C, and we do. So the code works, and that's about for the code demonstration. Okay, that's it for this video on the arrow operator. Thank you for watching, and I'll see you in my next video. Bye.